morning to all listeners who joined this Maintenance X conference. Now, we'll be discussing a certain methodology called reliability-centered maintenance and why it fails in most industries and what we can do about it. Okay, so this is my presentation. And first, I just would like to assume that we have listeners who are implementing and listeners who may not know what this RCM is all about. So let me just give a brief summary on what RCM is and what it can do. Okay, so at this moment, kindly imagine one of your assets, equipment, or systems right now. Okay, so let's imagine that this is your asset, and throughout the years that it's been operating, this asset or machine can fail in more than 100 ways. Okay, so let's assume that these are the failures, and typically what happens is that every time industries experience a failure or a breakdown, okay, what we do in most cases is that industries will default on placing a preventive maintenance activity in order to address that particular breakdown. Now, so every time there is a breakdown, typically this is what they do. And this is being done as a result of corrective actions or to comply with audits, customer issues, and whatnot. Okay? But what we fail to realize is that preventive maintenance alone cannot capture all failures and breakdowns on the equipment. So an alternative method had been developed so far. There are 4 pioneers in, if we go to the beginning, we have Nolan, Heath, Menzer, and Mattison. They developed a process to address this issue. Okay, so what we want to do is we get our best people and let them try to list all the possible failure modes that can affect the asset. Okay, so once all the failure modes had been listed, the first question in mind to raise is which of these failures can be prevented. So this can be identified and perhaps this failure can be prevented. So we apply preventive maintenance tasks on these particular failures. Now, there will be failures that cannot be prevented, but it can be predicted. So we identify them, and once we identify them, perhaps these failures can be predicted. Okay, so we apply our predictive maintenance or condition-based, RCM call this on-condition tasks. Now, there will be failures that cannot be prevented, and likewise, it cannot be predicted. So, but when the failure do happen, the consequences is low, or it can be allowed to fail. So we just identify them and then we just allow them to fail. So perhaps this failure can be allowed to fail because their consequences is not of that great impact. And lastly, there will be failures that cannot be prevented. It cannot be predicted, and also it cannot be allowed to fail. Okay? So what we can do in maintenance is to identify them, study their weaknesses, and we try to modify them. So perhaps this failure will be under the default of modification or redesign. Okay? Now, so in performing RCM, the first thing we need to do is what you call to determine the equipments or assets operating context, in which, in this case, we just write a short autobiography of our equipment. Now, meaning, is your equipment running for 24 hours a day, 7 days a week? Are there any peak months or peak periods in which your equipment is running? So, for example, if we are working in Coca-Cola, perhaps the summer months will be at its peak. Okay, so the equipments will be fully optimized, and if we can discuss what are the most common failures that we experience on our equipment and assets. Now, so this is how we write the operating context, and after that, we perform a very simple FMEA in which we will be deriving what you call the functions, functional failures, failure modes, and the effects of the failure. So they will be written what you call in a form which is called the RCM information worksheet. So once we have derived the first part in which we indicate the functions, functional failure, the failure modes, and the effects, okay? So this FMEA or information worksheet will be subject for an algorithm or decision diagram so that we can derive the most feasible maintenance tasks in order to what you call to be proposed in order to address that particular failure mode. Okay, so this is how it's being done. So if you think about the process, it seems to be what you call a good process. So it's good enough. And the question is, why do many industries fail in their RCM implementation? And how come many industries are not implementing it, most especially what you call the manufacturing, okay, the manufacturing industries? And can we do something about that? Okay, so to kick off, why many industries fail in their RCM implementation, I think the first and foremost, although this is not listed in any particular order, and I just can give you what you call the main gist, but I'm sure there are more. First will be what you call how we select the team, okay? So if we go about the definition, the technical definition of RCM, okay, RCM is a process used to determine the maintenance tasks, the maintenance activities, the requirements of our equipment's physical asset in its current, present operating context. Or a lighter definition is that RCM is a process that is used to determine what must be done so that we can ensure our equipments, our assets will continue to do whatever the user wants them to do in its present operating context. So it means that RCM is a process to derive what you call the maintenance tasks and maintenance requirements in its current physical condition right now, okay? Now, I also added a human definition of RCM. So if we talk about the human side definition, RCM is a process, a way, or a method of capturing and extracting what you call the knowledge, understanding, and the wisdom of the most experienced people in your plant and transforming it into a living document as well as their legacy. Okay? Now, one thing of most important that if we will select a team, there should be at least a minimum of one operator to be part of the team. So, if we ask who are the best people to compose the RCM team, I think the answer here is that this will be your plant's rolling stones, okay? So it means that if TPM is for everyone, now RCM is for the most experienced people, okay? So the problem is that most experienced people in the plant should be the ones to compose what you call the RCM team with an experienced operator. Now, the problem mostly is when these rolling stones, these experienced people leave the plant for good, their experience goes with them to the grave, okay? Now, what happens then is that either the industry will hire a fresh graduate, a cadet engineer, or a newly graduate person with little or no experience, and he will again find his way throughout the plant, and the cycle will continue for decades, just like a merry-go-round. Okay, so RCM can be used what you call as a tool in order to capture whatever these people know, their knowledge, their experience, their wisdom before they leave the plant and retire. Okay? So, although I would recommend that the new ones should not be initially part of the team, but it does not hinder for the new people to attend what you call the RCM meeting, because this is a very good learning venue for them, especially when these people brainstorm. Okay? So, that's the first on my list why RCM fail, and second, we have what you call a lack of management commitment. Okay? Now, I would prefer to use the word commitment rather than the word support. Okay? What we need is not just support in RCM, but what we need is a commitment. And if possible, what we need is ownership. Okay? Management can support, but they can never commit to the initiative. Okay? Because when we implement RCM, it will require an initial budget. Okay? So the budget will be for the training, depending on what you call the firm, the organization, and some of these training organizations who conduct RCM, they will require you to have what you call an RCM facilitation, meaning you will be selecting the pilot asset or system or equipment to undergo the RCM, and they will be what you call joining in to guide and facilitate the team until it will be completed. So I believe the facilitation is a bit more expensive than the training. So it depends on how large your asset is. Now, if there are protective devices, or if there are anything on your equipment that's not working, that's not that have malfunction, then it should be restored. Okay? So because these protective devices are our defenses on our equipment with respect to the failure. So if we will be needing instruments, predictive maintenance instruments, now we need to invest. Okay? Now, not only on the instrument, but as well as the user, because there are certain level of certifications that the user needs in order to use the instrument, meaning the user must be familiarized not only with the instruments, but as well as the principles of the instruments. So if they plan to acquire an infrared thermography, okay, the user must be well enough familiar with what you call the transfer of heat, because heat can be transferred, it can be reflected, it can be retracted, it can be absorbed, but the instrument, what we are interested is what the equipment heat that is emitted from our equipment. Okay? And there will be cases that there will be changes in the maintenance task, and it will also require a budget, especially if the task will be done by third-party contractors. Okay? And one thing I see during the times I was still employed is when we're conducting RCM, some management pull out their members or their people in the meeting. This will highly demotivate the team. Okay? So it means that my advice is that do not implement RCM if there will be no management commitment, because everything will be just a waste of time, efforts, and resources. So whenever there is a training, for example, you initiate an RCM training, include your management in the training. So if the schedule will not permit, now I recommend that someone or somebody provide a management overview, okay? So that you can speak the same language, okay? Now, RCM is a good strategy, but one thing I do not see in the RCM process is they do not address the small things, okay? And what I learned from the Japanese people is that this majority of these small things create problems, okay? So if we talk about lubrication, if we talk about lubricating oil, what the human eye can see is in the range of 40 microns. But according to tribologists, those specialists on lubrication, the smaller the contaminant, the more destructive it can do inside our equipments and asset. Okay? Now, RCM will address the failure modes by assigning a specific task that will be part of the maintenance or the operator routine activities. Okay? Now, however, if we talk about the basics, meaning your equipment lack bolts, your equipment is too dirty, the people do not understand what lubricant to use, so RCM will not address this. Okay? Now, a much better approach will be to address the basic first, for the basic equipment condition, before implementing reliability-centered maintenance on our equipment and asset. This will yield much better result. Okay? Now, for example, what good should the top-of-the-line 2021 model vibration monitoring, which can measure several frequencies, if your equipment lack a couple of bolts? Okay? So definitely, if you lack a single bolt, it will expect the vibration to increase. And majority of the failures, most especially random and premature failures, are just an accumulation of small problems that we try to neglect on our equipment and assets. Okay? Now, condition-based is a good strategy, but it is not a perfect strategy. Okay? Why? Predictive maintenance, condition-based maintenance will answer when your equipment will fail. So if we have a bearing and we have an L10 and we have a given reliability of 90%, it means that the bearing's life is 9 years at 90% reliability. Now, condition-based maintenance will only detect when that particular bearing will fail. If it will fail after 6 months, it will be detected. If it fail after a couple of years, it will be detected. But it is not a guarantee that the life of the bearing will be maximized at 90% or 9 years. Okay? Now, predictive maintenance can predict the failure with once a potential failure had been detected, but these instruments will not guarantee that the lifespan of the part or item will be reached. Okay? It will just tell us when it failed. Okay? Now, I have several references here. Books about Japanese authors, TPM authors, okay? And if the author is Japanese, I seldom see the word random failure. Now, they use the term accelerated deterioration, okay? And according to my good friend, Kate Mobley, random failure exists because we made them, okay? What do I mean? Typically, when a failure happens, we address them, we perform corrective maintenance, but unlikely if we will perform a root cause to better understand the cause of the failure. Okay? So if this becomes a habit upon industries, then it becomes a random failure. So my recommendation is that before implementing RCM, we take care of the basics of our equipment. Okay? Now, fourth, we have a biased outcome of the maintenance task. It means that I call this the cut and paste syndrome. Okay? So it means that typically an industry have their own preventive maintenance activities. So they have the tasks listed. And when deciding on the most feasible task to address a particular failure mode, the RCM team might be tempted to just cut and paste their existing preventive maintenance tasks just to complete the RCM process. Okay? So, for example, we have a preventive maintenance task that indicates we need to change the oil every 500 running hours. Okay? Now, what we need to do when we are performing RCM will be to challenge the team if there is a better way of doing the task compared to what we have been doing previously in our current preventive maintenance. So the team should brainstorm if there is a better task instead of just cutting and pasting their existing tasks to the derived RCM. Now, if this will be done, then nothing will change. Now, for example, I have here change oil after 500 running hours. So perhaps a better task will be to place the oil on condition base instead of running hours and check and perform, let's say, a regular offline filtration cleaning, and likewise conducting an oil analysis such as particle count, TBN, Fourier transform, infrared, moisture, rate of oxidation, and so on the maintenance task. Thereby, we can extend the life of the lubricating oil. Okay? Now, also, when you perform RCM, you need to be precise on how you indicate the task, because most of the tasks might be done too soon, okay, or most of the tasks might be done too late, in which the failure already happened. Okay, so it means that when we perform an RCM, it will only ask you the initial interval. Okay, now the team that is conducting the RCM analysis must assume that they may or may not be performing the task, or other people might be performing the task. So it means that the task to be done must be in detail. Now, we can adapt, we can apply precision maintenance in writing the task. So the concept of precision maintenance is that whoever is doing the task, whether you are the most experienced or you are the least experienced among the maintenance craft, will yield the exact outcome, okay? The exact outcome of what we want the equipment to be. So, for example, we apply precision maintenance in our lubrication, so it should be in great detail, okay? So, for example, I have here an interval for greasing, around 42 days, operating temperature, assuming it's around 41 degrees centigrade. The equipment temperature is around 150. I use a K factor of 1. Type of lubricant, lithium grease. Brand, Shell EP3 lubricant grease, high temp. Dropping point of the grease is at 227 degrees Fahrenheit, while the usable temperature will be at 177. Now, precise amount of grease to be applied, 150 grams. Type of grease gun, Trico brand with meter reading, and the responsible person, okay? So this means this is how detailed we should write our maintenance tasks, so that whoever is doing the task will not assume but perform it what you call precisely as indicated, so that it will yield the same outcome or the same output. Okay? So what is important is that we derive the correct interval, because in RCM, when the team propose a task, okay, usually the interval will be either brainstorm, or it might be daily, weekly, monthly, quarterly, semi-annually, and so on. Now, most of the output of the team, when we talk about deriving the interval, will either be because of a product of either brainstorming or copying the existing interval they have on their preventive maintenance, or it's just some guesstimates, okay? So when we select the interval, okay, now for each related, for example, if we talk about preventive maintenance overhaul, now we can use what you call the age exploration technique or age exploration method for conducting an overhauling or replacement. It means that our interval should be based on the majority, on when those majority of parts will fail. Okay, so for example, we have a yearly replacement of an impeller in the pump. Okay, so we replace it yearly. So when the year comes and we try to replace the impeller, and we observe that there is just a very, very slight wear out on the impeller, then we can increase what you call the interval by a factor of 10%. Okay? So it means that in 1 year, you have 365. So multiply that by 10%, you have 36.5. So our next replacement of the impeller will happen next year plus 36.5 or plus 30 days or on the 13th year. Now, if still there is no wear out process, we still increase by 10% until we can see a wear out. Okay? So I borrow this concept from Anthony Smith, which is one of the pioneers of RCM. Now, for failure finding tasks, you need to have what you call, you need to know the mean time between failure, and we have a table for selecting the correct availability. So if this is a critical protective device, meaning failure finding will only apply for hidden failures, most especially protective devices. So if we have a case of very sensitive or very critical protected device, then we can aim for a higher availability, let's say 99.99. But if we have what you call a protected device which have some redundancies in the component, then we can aim for a much lower availability, let's say 99 or 95%. Okay. Now, for routine inspection, now we can use MTBF because MTBF is an average, okay, or we can use MTBF, but you just lesser the value by 10%. So if the MTBF is what you call 1 month or 30 days, we need to perform the inspection before reaching the 30th month. Okay. Now, for switching redundancies, let's say you have a component and you have a backup or a duplication, we can use a 3:1 or 5:1 ratio. Okay. Now, I usually tell the people I teach that I would not advise giving a 1:1, meaning you will run the equipment for 1 week, stop it, and then go to the redundancy and run it for 1 week. Okay. Now, the problem with that, having the same frequency, is twofold. First, it's too frequent. Okay. So the more you start, the more chances of failure. And second, since the interval is the same, there is a probability that some of the parts will fail at the same time. Okay. So meaning, if I have a redundancy, maybe the duty pump can run 3 months and the standby pump can run at 1 month. Okay. And for greasing interval, you can use this what you call formula, which I derived from the book on the STLE Handbook about Lubrication and Tribology, volume number 1. Okay. So K will represent the actual condition of the equipment. Okay. So this will be a factor of the temperature FT times the contamination FC times the moisture FM times the vibration of the equipment FB times the position, if this is a horizontal or vertical FP, and what is the design of the bearing, which is FD. So if you are on a worse condition, you aim for the lower value. Okay. You aim for but if your condition is not so harsh, you can use the factor of 1. Okay. You can use a factor of 1. So I think one of the this is, I would not say that this is why RCM failed, but if we implement RCM, do not think RCM as a one-shot solution to all our maintenance problem. It is not. Okay? It is not. Now, RCM will deal with the failure, with the equipment failure. That's good. Okay? But it will deal with the failure, but not all the losses, especially for manufacturing. Okay? Now, if I may explain this the simplest way I can, okay? Failure are simply part of the losses, okay? Meaning losses are the bigger problem, and failure is just one of them, okay? So, if it's a Friday or TGIF and you and your friends want to go and eat a pizza pie, usually when we order the pizza pie will be cut in 8 pieces, okay? In 8 pieces, and each of these pieces will represent what we call the different losses of our equipment, okay? So we have the breakdowns, setup, okay, startup, minor defect, cutting tool change, design speed loss, defect, shutdown loss. So it means that unlike power plants or unlike oil and gas, manufacturing industries have a much broader problem in terms of losses. So you might have an equipment that do not experience so much breakdown, but experience a lot of minor stoppage. Or you have an equipment that is not dedicated, in which it is being converted or set up from one product to another, and this is what is eating your downtime. Okay? RCM will not address those issues. So addressing all the possible losses on our equipment and assets will require different strategies, methodologies, way just beyond improving the way we maintain our equipment. Okay? So, for example, your problem is set up because you have a lot of products to manufacture in that particular equipment. No amount of maintenance tasks can solve that problem. If you want to shorten your setup time, then you need to purchase the book of Shigeru Shingo and implement his technique called SMED, or single minute exchange of dice. Okay? The key is for our maintenance people to understand what are the different losses, or what is that particular loss that your equipment is suffering, and apply the most feasible method in order to reduce, mitigate, if not eliminate that particular loss. Okay? So, for example, these are the losses, and these are my recommended strategies in order to address every specific loss. So, for RCM, perhaps it can improve breakdown loss, conversion. No, it will not improve the conversion. Cutting tool, you need to have a different strategy, such as modification. Startup loss, shutdown will be improved. Okay? Now, idling, no, it cannot. It's a different problem. Okay? Design speed, I don't think so. And for quality and defect, it will only address the quality issues that are attributed to the equipment. But if we talk about quality problem, the costs are broad. So if the cost of the quality is raw materials, definitely RCM will not address them. Okay? So it depends on what losses you suffer from that equipment, and what you call, use the correct methodology. Okay? And lastly, okay, I think one of the reasons why majority of industries fail is that they're not ready for the RCM, or their culture find it difficult to accept the RCM process. Okay. Now, once you have been trained on analysis, I'm confident you can finish the analysis. But implementing the RCM process, we provide a time when we will start the RCM on our equipment. This will be the challenging part. Okay? Doing the analysis will be easy. Implementing the RCM will be challenging. Okay? So when RCM will be implemented, the deal will be your current preventive maintenance task should stop. It should be superseded by the RCM task, okay, or the task that had been derived by the RCM team. It should supersede what you call your current preventive maintenance. You cannot perform them simultaneously. Okay? Now, so what I meant is that before we can implement RCM or the method, you need to believe, you and your people as well as your management need to believe in the system. Now, it should not only be a team initiative initiating the RCM analysis that needs to understand the principle, but this goes to the very people in the plant and outside the plant who have affected the way we perform maintenance. on our equipments and assets. Okay. Now, there is a quote on maintenance that 17%, 17, of equipment-related problems, breakdowns, quality defects, issues, incidents can be considered as maintenance-related. But 83% of equipment problems, incidents, failures are way beyond the scope of maintenance. These are called non-maintenance induced failures. Okay? So, what RCM would want to do is for us to understand the different patterns of failure. We have infant, random, age-related, and then based on the pattern of the failure, RCM will try what you call to recommend a particular task. Okay? So, in order to reduce infant mortality, we apply precision maintenance on the way we perform preventive. Now, if the failure is random, we can either use these instruments, condition or predictive base, or if you have a protective device that can fail randomly, we can apply a failure finding task. Or if the failure is not critical, or the consequences is not that high, we can just allow it to fail. But if predictive failure finding run to fail will not address or resolve the failure, then this will default to redesign or modification. And for age-related failure, we have preventive maintenance. We can apply preventive maintenance. Now, once we determine the task, the correct task, okay, so for run to fail, the question is, do we have a standby? Do we have backup? Do we have a form of duplication? Now, if we have some duplication around on our component, then we what you call create a switching frequency or a switching interval. Now, if some of our assets do not have, or components do not have a backup, then the question is, do we allow it to fail? Okay, can the failure be allowed to happen? And for run to fail, we can adapt or we can perform another strategy, which is called root cause failure analysis. For failure finding tasks, this can be done on protective devices. Okay, and once we have determined the maintenance task, then we can derive the correct interval on performing this task. So once we derive the correct interval, then we can now address our spare parts requirements needed on our equipment. And once everything is done, we ask the question, were we able to prevent, to predict, to prolong, to contain, or to anticipate the failure before it happened? Now, if yes, then we're done, we're good. Okay? Now, if no, then either we modify or we just allow the failure to happen. Okay? So the only way of knowing your success or failure in your RCM implementation is not by the consultants, but by the indices, meaning before implementing and after implementing, give it, let's say, 3-4 months after implementation, measure your KPI, downtime, breakdown, maintenance cost. These indices will spell what you call your success or failure in your implementation. Okay? So, to conclude, a more holistic and better approach will be, we have the RCM methodology. It is a good strategy for determining the correct maintenance tasks in our equipment and assets in order to provide a sustenance, okay, on the failure. But what I do recommend is that before initiating RCM is that address first what you call the basics. Okay, so these are the little things that we neglect, okay, on our equipment. So address the basic first before implementing RCM. And for those failures that repeat itself, okay, so what we can do is we perform a root cause failure analysis. So whenever a failure happens in your industry, okay, whenever a failure happens in your industry, or if the failure persists, okay, let the team ask, will the failure warrant a root cause failure investigation? Now, if we answer no, go ahead and repair. But if you want, or it is necessary to conduct a root cause failure analysis, first thing you need to do will be to preserve what you call the physical evidence. Okay? So I think that's about it. That concludes my presentation. And I hope that you learned something from this brief. And these are the books I have written and still writing. Okay, these are in series, and you can find this on these links if you want to know more about maintenance, okay, and reliability. Okay, so I think that's all I had to say about that, and I thank you, IK Knowledge, and the listeners for having me around as one of your guest speakers. So I think this is about it. Thank you.
Thank you very much, Mr. Rowley, for your presentation. Now, ladies and gentlemen, the IK crew would now like to share a short video on behalf of Mr. Rowley, but I would also like to remind our participants that you may post your questions for Mr. Rowley regarding this presentation in the Q&A box. So whilst we are preparing the video media for all of you, go ahead and ask any questions you may have to our speaker.
If you think the training is expensive, then think about the cost of repairs and breakdowns. It is much more expensive than training itself. Some say that changing culture should start on the top. Others says it's a bottom-up approach. There's no easy and conclusive answer to this, but all I can say is that change is something that must start from within. And I think nobody says it better than the late King of Pop, that change must come from the man in the mirror. Always remember that in any reliability initiative, focus should always be given to the people. Provide them the knowledge they need to do their jobs correctly. Remember, it will be the people who will improve the equipment, and it cannot be the other way around. In a reactive environment, we always complain about the lack of maintenance resources to address equipment failure. Remember, maintenance is not measured by how fast they repair their equipment, but how we were able to analyze the failure themselves. Is 80% people and 20% equipment. Focus on the people, and the people will focus on the equipment. The level of achievement that we have at anything is a reflection of how well we were able to focus on it, because the only thing that's holding you back is the way you're thinking. By Steve Vai. The message of root cause failure analysis is simple. Industries can only learn from the things that go wrong if we can accept the fact that we too are also part of the problem. All failures are not created equal. Every failure will have their own degree of consequences. Being proactive has something to do about reducing the consequences of failure rather than eliminating the failure itself. The most important reason why we maintain our equipment is because there are times that the consequence of failure is far more important than the failure themselves. People are not the company's greatest asset. The right people are the company's greatest asset. The wrong people are called liabilities. And we can only have the right people if they are equipped with the right knowledge to do their jobs right the first time around. In any reliability and maintenance improvement strategy, we do not need management support. What we need is management commitment and ownership. Remember, management can support but never commit to the initiative. And lastly, knowledge and education is what maintenance need in order to fulfill its function. As a maintenance myself, I humbly ask, let us not deprive our maintenance people with education, because that is all they ask for. So this is your speaker, Rolly Angeles, a maintenance preacher in a small-time institution. God bless you all, wonderful people. So that ends my presentation. Thank you, Sean, for letting me play that.
Thank you, Mr. Rolly, for that video presentation. I do have a couple of questions from the floor for you. And our first one is from one of our delegates, and they're asking, hi, Rolly, how should we convince management to adopt the RCM initiative and strategy? How do you justify it in dollars and cents?
Okay, first, I will not recommend first RCM to be done on critical equipment, but on all equipment, but just on critical. Okay, so if I were you, you have attended the training. My advice is you select your rolling stones, organize a team, select one critical, measure the indices in terms of cost, repair, okay, downtime, and so on. Perform the analysis and then implement it for the first 3-6 months. And once you have generated what you call the change in your indices, let's say the cost was reduced, the downtime was reduced. Now you have what you call, you can set what you call a management meeting. But before the management meeting, someone should what you call provide, let's say, a 1-hour overview on RCM, and that you tell your management you want to present something. Okay, so once your management saw your indices, the costs have lowered, number of downtime, number of breakdowns have decreased, they will ask you how. Okay, so this is now your selling point. This is how to convince management to be on our side in order to what you call have the RCM implemented in our plan. Start small, okay? Earn the success story and then share that to your management. That would be my advice, okay?
Thank you for that response, Mr. Rolly. Actually, we have a few more questions from the floor, and the other one is from Chandra Gonadi and from PP Waskita Betonprikas TBK. And it's a similar question to another question that was asked by another attendee, but they perhaps would like to know, is there any strategies you have that you could maybe sort of convince management to really commit and give and, you know, claim ownership over the RCM implementation process? Maybe not just in terms of dollars and cents, but what else could you say or what could you present to management?
Now, for management presentation, okay, now this will only happen, your question will only happen if your management is a non-technical, I mean no disrespect, okay? But in my experience, if this is a maintenance manager, they will provide you the things you need. Okay, they will provide you the things you need in order to conduct RCM. But if this is the higher management, I think the first things first is you need to conduct what you call a presentation with them. And just be detailed in your presentation to include what you call benefits and to include what you call monetary value. For example, this industry have implemented and they save their maintenance costs by a reduction of 30%. So we can do the same if we have the resources and training, because they will only understand us if they see what you call a return. Because conducting RCM is an investment, okay? So we need to take away money, but when will we get back our money? When will be the return or the payback or the return on investment? Now, if you can show that to your management, then I think there will be more than 50% chance that management will be on your side. Okay, so I think this is about it.
Okay, Mr. Rowley, thank you for fielding a question. I have one more question from our participants for you. And it's from Guha Prasad Swaminathan from Indorama Polyester Industries. And they'd like to ask, hello, Mr. Rowley. Thank you for your RCM session.
Thank you.
You were informing us about the lubrication part of equipment and how it can be filtered and reused to avoid change of lubrication. So they would like to know what properties they should be maintaining in the filtered or debris oil. And they'd like to know this to ensure long-lasting life of the equipment with the filtered oil.
Okay, first, if you want to know the length when your oil will expire, there are several tests. Okay, you have the ruler or the remaining useful life of the oil, and another oil analysis test is what you call the TAN TBN crossover. Okay, so it means that when your oil was new, the value of the total base number is high. Let's say 10, 12. And the total acid is very low, the acidity of the oil. As you use your oil in your equipment, the total acid number or the acidity will increase and automatically the base will decrease. So let's say you have a value of total acid number of 0.2, 0.3, goes up to 1 to 2, automatically the base will increase. Now, once the value of the TAN and TBM becomes equal, let's say the value of total acid number is 3, TBM is 3, you have a crossover. This is the recommendation when what you call to change the oil. But if you're talking about what you call a more holistic oil analysis approach, okay, there are 3 levels, okay, to be done to have your oil checked on a laboratory. The first level is to check the oil for its health and cleanliness. And this will be done using what you call a particle counter to check how clean or how dirty your oil is. Now, once level 1 is done through a particle counter, the same sample will go to level 2. And level 2 will check the oil for its physical and chemical properties. You will be having a series of tests depending on the oil. Okay, let's say check for viscosity, moisture, TAN TBN, okay, oxidation, and this, in order to determine the physical and chemical properties. Meaning, the purpose of level 2 is to check if the additives are still in the oil or have been depleted. Okay, so once you complete level 1 and you complete level 2, it goes to the final level, which is level 3. Okay, I'm talking about the same sample. So level 3 will check the oil for the different elements, metals and non-metal. Okay, so as the maintenance, you need to be familiar with the limits of every element. And each of the element will represent a problem. Okay, so for example, you have an engine oil, you have a high contents of chromium. For the past 2 or 3 readings, it means more probably the piston rings are starting to wear out. Okay, so when doing oil analysis, it should be done in 3 levels. Level 1, checking for oil health and cleanliness. Level 2, check for physical chemical properties. Level 3, check the oil for the different elements. So if you want to know how to extend the life of the oil or the lifespan of the oil, you can use a ruler or the TAN TBN crossover. That's my answer, Sean.
Thank you very much, Mr. Rowley. I appreciate the fact that you fielded all those questions. I also like to thank our participants for those questions.